Today we are going to take a very important topic that is called project crashing. This is very important, as I have explained in one of the last lectures, that why it is used and where it is used and how it is used. Number one thing is that I already told you, when from event 1 to event 2 you have activity A and it is taking 5 days, for example. This we have considered right from beginning. Now A needs at least 5 durations, 5 days of duration. Now this 5 days of duration will also takes cost, or it incurs cost. Cost for how many days? Cost for 5 days. This we call it as a normal cost. This cost, if it is taken in a normal way, whether it is critical or not critical, whatever it is. But as per our earlier problem, this was critical. This activity came out to be critical. So this activity normally takes 5 days of duration and cost for 5 days. Maybe for example say 4,000 rupees. So when this is taken as this 4,000 is taken to be the normal cost. This 5 days will be taken as the normal time. How this 5 days comes and what it is, how does it is considered for all that we have seen in work breakdown structure and so many other topics. Now, if this 5 is the normal time, maybe 4,000 will be normal cost for 5 days. This is okay, it is going on smoothly, for example. Now, as I told, there are so many reasons why a crashing has to be done. I mean, crashing is the technique of compressing the network. Suppose network is taking, what was the TPT in our first problem? Maybe 17 days. Now this 17 days is the normal time, normal duration. I mean, if it is done in a normal way. Now this, we don't want this project to be completed in 17 days, but in a less amount of time. Why? Because there are so many obvious reasons. For example, that as I told, the Muhurtam is coming near, or the Prime Minister is coming to open all, some minister is there, or some event is there, or some particular program is there, or they want it to be completed before so and so date. Like that, there are so many reasons why, or maybe monsoon is coming, maybe rains will come. So all these things are taken care in a cost where we try to reduce this. How much can be reduced? It depends upon the network. How much the TPT, total project time, can be reduced. It all depends only on the network, what you have done. I mean, the network clearly says, suppose you can ask me, can we complete this, can we reduce this to 13 days? No. What I will say is that the network itself will give you the solution. The network will tell you whether this can be completed in 13 days or 14 days or 12 days, depending upon the network and one particular aspect that is called to be crash potential, CP. Depending upon the crash potential, the network itself will dictate the solution. I mean, suppose if I have to do this solution, if somebody is doing in some other country, if somebody else is doing in this country, or whoever is doing, the network solution for this, how much will be the total TPT, is fixed. Suppose if I am doing, I cannot reduce to 12 days. If you are doing, you cannot reduce to 13 days. You cannot. Wherever, in whichever country or whichever globe you do, the solution is fixed. That solution is dictated or directed by the network itself. What network we are considering, what numerical problem. Based on that numerical problem, you will get the TPT. I mean, reduced TPT. So suppose if I say this 5 days duration, it can be reduced to 2 days, or it can be reduced to 3 days. I will write in bracket, this will be the normal time. This can be indicating the crash time, CT. This 5 is the normal time. This 3 in the bracket assumes that CT, that is the crash time. That means activity A, which can be completed in 5 days, which may be critical, which needs 5 days as a normal duration to get it completed, it can be reduced to 3 days. That means what margin you will get? You get 2 days as CP. You get this 5 minus 3 is 2. 2 is the crash potential. So that means this one minus this one will give you how many days this activity can be reduced. So this can be reduced to 3 days. I mean, by reducing 2 days, this activity will take now 3 days. So I will put here 3 days. Now, can you ask me, can you reduce to 2 days also? This one? You cannot, because this is the final. So you cannot reduce to 2 days this one. Now, suppose if you are trying to reduce duration from 5 days to 3 days, 2 days you are saving. This saving, it will incur more cost or additional cost. So this one will become 4,000, which was the actual cost, plus for 2 days maybe 1,000 rupees. So now the new cost is 5,000 rupees. Now this 5,000 rupees is required to complete activity A in 3 days. That is the reduced time, that is the crash potential time. So this cost will be called as the crash cost. Crash cost. So what all they are called? 5 is called normal time, 3 is called crash time, 4,000 is called normal cost, and 5,000 is called crash cost. So 4 items will come here. Normal duration, normal cost, crash duration, crash cost. So what is crash duration? Crash duration is 3 days. So this is what exactly as per each activity you have to consider now. I mean, first you need to see that whether there is a crash potential available with each activity. Now how many days? You have to take the minus. To take 2 days. 2 days you can reduce, because 5 minus 3 is 2 days. So you have 2 days as a crash potential. So for each activity, you need to see what is the crash potential available. Number one, first thing. Now the process starts from the critical path. Suppose where the crashing will occur? Along the critical path. Now first you need to consider the critical path, because critical path is supposed to be the longest path. So try to take critical path first, try to evaluate that, try to identify in a network. Once you identify critical path, then you list that what is the TPT, how much is the total project time it is coming via critical path. Then if there are any other paths, maybe 2 paths, 3 paths, 4 paths, there can be any number of paths. I think in first example where we have taken, we had 2 paths I think. So if you have these 2 paths, from 2 different paths, how much will be the TPT is coming? One from critical path it is 17, maybe from the other path it is coming as 15. So what you can do is, when you try to reduce this, you can reduce here also by 2 days. So the total, once you reduce here 2 days, there the time will be reduced to 15. Now once critical path also becomes 15, then another path is giving 15, critical path is giving 15. Then you need to check whether the other path also, which was not critical before, now becomes critical. So that means the same network what we had considered earlier will be getting now, after reducing this by 2 days, as 2 critical paths. Now when the timings match TPT from all the paths, then you need to reduce simultaneously from both the path if you have crash potential. If you don't have crash potential, then the problem ends. So that's exactly what I was telling, that the problem will dictate you in how many steps the solution will come. This is a very difficult norm which many people they don't understand. Many teachers, textbooks and PPTs and all that, they don't give you this clear idea. This is the exact clear idea where the solution is dictated by the numerical problem itself, the network itself. But many people they get confused and they will not be able to clearly indicate to you the correct procedure what we have to do. So what is the procedure at the beginning now? First thing is to check for critical path. You identify the critical path first. First step will be to identify critical path. Second step will be how many paths are there. How many paths? From where to where? from event, initial event, that is 1, to terminal event, that is end event. So from initial event to terminal event, how many paths are there, that you need to identify, and all along with this one will give you TPT, this also will give you TPT. So project completion times you have to even calculate from different paths. So then you arrange, maybe one path gives 17, another path gives 15, another path gives 13, like that you have to arrange in a descending order, because we need to go on crashing the network now, depending upon the potential available. So the next step will be to identify the crash potential. After this, third step will be to identify the crash potential. Whether crash potential like 5 and 3 I have given, that means you have 2 days as crash potential. Like this you have to identify. The fourth step will be, you need to find CS, that is called cost to slope. Cost to slope will be given as CC minus CN by TN minus TC. What are this? This is crashing cost, crash cost, normal time, crash time. Because crash cost will be more, normal cost will be less, normal time will be more, crash time will be less. So that is why this is the formula to be used. And using this cost to slope, you need to know, suppose this is 2 days, you get this value as maybe 50 rupees. Then this you need to mark on the network, the cost to slope, because next step will be, among the critical activities or among the activities along the critical path, you need to consider the least cost to slope initially. So first step will be this, first step of the process, crashing. What is the first step? Once you know TPT, once you know these timings, once you know crash potential available, you know the critical path, and you know the cost to slope for each one. For each activity you have to calculate this and mark on the network. Now, once you mark on the network, you need to consider in the first step the critical path. Among the critical path, there will be 2 activities, 3 activities, 5 activities, whatever be. I think in our example, what we have considered, there were 3 activities. So, among those 3 activities, which critical path activity or which critical activity has the least cost to slope? So, you need to arrange them in the descending order. Activity A, 50 rupees, activity B and activity D. So, activity B may be 40 rupees, activity C may be or D may be 20 rupees. So which one you have to crash? You have to crash the critical activity in the first step, which is having the least cost to slope. That means 20 rupees, for example, D. If D has the crash potential, CP, you reduce as much as. But in the meantime, you have to see this also. How many days you have to crash? If you crash more than the number of, TPT which you get from the other path, then the whole path will become distorted. It will not work. The project will be distorted, and the lot of troubles will come. So that is the reason why you need to consider least cost to potential, no, least cost to slope here. You need to consider least cost to slope for the first step. Then go to the next cost to slope, next one, next lowest. Then next lowest. But all the time going on noting down CP. If crash potential is available, only you can do. If suppose the other path has also become critical, then you have to reduce simultaneously from both the paths. Simultaneously, how you will take? There is a problem there. When other path becomes critical, this is a little bit you need to sincerely hear. When other path becomes critical path, then you need to reduce network from both the paths. That means if crash potential is available with this one and with this one, you need to reduce by same time, because the timing will be same. From both the paths you have to get same timing. But when you consider these two, you have to add cost to slope of this activity, cost to slope of this activity. When you add this, go on adding for all the critical activities along both the paths, and the least of that, I mean a combination of this, when you add it, the least cost to slope among them should be taken as the second step. I hope it is clear. This is a very tricky step you have. You need to open your ears and mind and then try to understand that. When other paths also become critical, when you in the first step, when you reduce the network, then you need to take our crash potential if it is available with this path and this path, two paths, then you have to consider cost to slope of this, cost to slope of this, or cost to slope of this, or cost to slope of this. For combination of activities, critical activities, you need to work out the combination where you get the lowest cost to slope among them. Only in the second step, that particular number of critical activities will be reduced. Maybe for how many days, depending upon the crash potential. If one path has 1 day only left and critical path, the earlier critical path has still 2 days, you cannot reduce it. You can reduce only with 1 day, and the problem ends. So that's exactly what I was trying to say, that in the critical path, in the project crashing, the network given or the table given itself will clearly give you number of steps. In how many steps the solution will come, whether 1 step, 2 step, 3 step, 4 steps, like that. Sometimes it will go 5-6 steps, sometimes it will be end within 1 step only. So whoever does, either you do or me or whomsoever, whoever, teaching project management, if it does, the solution will come same. The solution cannot change person to person. So that is the reason why I will try to say that I will try to take a numerical example in the next lecture and then try to solve you the network crashing problem and then explain clearly. But these are the steps you have to follow every time. You cannot forget this. So I hope you understood. If you have any issue here or any doubt, please DM me. I'll be happy to answer to you. Please follow it up and then also share it with your friends and other colleges so that the concepts are very clear. Because most of the people, they are not able to give clear concept in project crashing. Even textbooks you follow, they will confuse you. So I will try to put forth before you very crystal clear concept and how it has to be done. Okay then, thank you very much. Enjoy your